Hello everyone. In this lecture, I shall discuss the order of convergence or the rate of convergence or the speed of convergence, okay, in a numerical methods. So, formally, what does it mean? It means how fast a sequence of approximation approaches to a true solution. Means you are given a equation f of x is equal to 0. Right, we find the initial approximation x1, x2, xn, right, and suppose my zeta is the root, here f of zeta is here 0. Now this xn approaches to here zeta, how fast it approaches, right, at what speed it approaches. So that is to be analyzed, what is known as the order of convergence. In general, from the viewpoint of analysis, suppose you have a sequence xn and it converges to a number zeta with this order of alpha n, right, this order of alpha n, or we call it big O of alpha n. Alpha n is another sequence. So this is with respect to this order of convergence is with respect to another sequence alpha n. If this xn minus zeta divided by alpha n modulus is smaller than equal to some constant c. So c is a constant, right, and which is independent of your n. C is your independent of your n, right, and this approximation means here how far large n is, means we may say we may tend n to infinity, no issue, right, we may tend n to infinity. So now here the order of convergence is compared with another sequence alpha n. But in particular, in numerical methods, right, basically we have an iterative scheme to solve a system of equation, right. We have a fixed point iteration, we have a Newton-Raphson method. These are all the iterative schemes, right. So in view of the numerical methods, right, on the basis of an iterative scheme, what the order of convergence is, right. So before I explain from the numerical analysis point of view, so let me to introduce myself, Professor Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. Right, so without much delay, let me to tell you what exactly we are going to analyze here in view of the order of the convergence. So in numerical methods, by saying the order of the convergence or the rate of the convergence, we mean that the errors here, okay, we'll compare the errors in two consecutive stage. Means we have the error in nth stage, we have the error is in nth stage, we have here error is here xn is suppose here zeta plus epsilon n, okay, zeta plus epsilon n. Now here in n plus 1th iterations the error is suppose here zeta and the error is my epsilon n plus 1, right. So now here I compare these two, right, I compare these two here, means I mean to say here the epsilon n plus 1 divided by epsilon n, right, this modulus to the power p here, right, is less than some c, some constant, then this p here is called the order of convergence or rate of convergence, okay, rate of convergence here. So let me to discuss the details of this definition. So here basically the order of convergence is defined in terms of the errors en and en plus 1. En is the error in nth approximation, en plus 1 in error in n plus 1th approximation. Means this error is, right, approximate root minus the real root here, right, in successive approximations, in two consecutive approximations, okay. So let me to discuss the details of this order of convergence, and in view of this convergence I will discuss here the rate of convergence of fixed point iteration method and NR method in details. Now coming to the definition, an iterative scheme, okay, an iterative scheme or process is said to have a pth order convergence if the error in n plus 1 step by the error in nth step and to the power p here, okay, is less than or equal to some constant c for sufficiently large n as n tends to infinity, as limit n tends to infinity, right? For sufficiently large n, c is a constant. What is c here? C is a finite constant here, right? And I may rewrite it here. Equivalently I may write it en plus 1 by en mod, this mode en plus 1 mode by en mod to the power p is less than or equal to some c, or this is same thing as en plus 1 mode is less than or equal to some constant times en mod to the power p. Then this p here is called the rate of convergence. Okay, p here is called the rate of convergence or order of convergence. So here this p is here rate of convergence or the order of convergence or the speed of convergence. Okay, so from the numerical analysis point of view, we compare these two consecutive approximations and we analyze the error here. So this is the rate of convergence here, but in general here the rate of convergence means we compared in comparison to another sequence, okay, and with the order of alpha n, right? So let me to discuss the rate of convergence of fixed point iteration method. Now let us discuss the rate of convergence for fixed point iteration method. Okay, what is the rate of convergence? In fact, the rate of convergence here is of order 1 to n, right? The rate of convergence is of order 1 to n depending upon phi dash x, right? Depending upon phi dash x, right? As you know, in viewpoint of their fixed point iteration method, for convergence what you need? Phi dash x mod less than 1, okay? So here the order of convergence is depend upon the phi dash x. So we will discuss in details here. Our discussion: consider an equation fx is equal to 0. Consider an equation f of x is equal to 0 and let zeta be the root of the equation lying in AB, right? So zeta lies here in AB. As such, you know the necessary formula. For iteration method, for fixed point iteration method is what? Is here xn plus 1 is phi of xn, right? It is in view of x is equal to phi x such that here phi dash x mod less than 1, here x here lying in this interval AB where the root contains, okay, is not it? We know this. So now in view of your error, what is error here? Here error is the approximate root, right? Xn minus here zeta. So real root minus approximate root. This is the error here, right? So now in view of this, we have here xn plus 1. So this implies xn plus 1 will be en plus 1 plus zeta, and phi of xn will be en plus zeta, okay? So what is your xn? Xn will be en plus zeta, is not it? So this is phi of en plus zeta. you must be knowing the Taylor series expansion. So you apply the Taylor series expansion here. Taylor series, you know what is the Taylor series? The Taylor series expansion is f of x plus h is f of x plus h f dash x plus h square by factorial 2 f double dash x on, and this is your Taylor series, right? So we apply this Taylor series expansion here. So this will be here f of xn, f of your zeta plus en f dash zeta plus en square by factorial 2 f double dash zeta, continue en to the power n by factorial n fn zeta and plus so on. Okay, so now what you know f of your phi of x is equal to x. So this is in fact your phi. This is in fact your phi. Okay, so phi. So what you know phi of x is equal to x. What does it mean? Phi of zeta is equal to your zeta, is not it? So this is your zeta. So what is this? This is your zeta now. Then zeta and zeta cancelled in both sides. Then what you will get? So this implies here en plus 1 is equal to, this is already cancelled, en phi dash zeta plus en square by factorial 2 phi double dash zeta, so on en to the power n by factorial n phi nth derivative at zeta plus so on. Now we impose the different cases, right? Coming to my case 1. In case 1, let your phi dash zeta is not equal to 0 and your en square, en cube, so on tends to 0 because your epsilon n is a small error. So still epsilon n square, epsilon n cube is very small and tends to 0. So let it be my equation star. So now from star, okay, from your equation star, your en plus 1 will be equal to en phi dash zeta, right? So this implies your en plus 1 mode is same as en mode into phi dash zeta mode. Okay, if this is my very close to C now, so then this will be equal to C into en mode. So what is the power of this? The power is 1 here. Okay, so what is the order of convergence here now? So here the order of convergence is, so this implies the order of convergence is 1 here. Okay, so now similarly we can make the order of convergence 2 here, case 2. In case 2, if we suppose that phi dash zeta is equal to 0, okay, but phi double dash zeta is not equal to 0 and your epsilon q, epsilon fourth, okay, your epsilon q and epsilon n fourth, so on, tends to 0 here. Okay, then what happens to your equation star? So this implies your en plus 1 will be equal to en square by factorial 2 phi n double dash zeta. If we let this is my C, then what will happen? So this implies my epsilon n plus 1, right? Epsilon n plus 1 will be epsilon n plus 1 mode will be this mode to the power is here now 2 here, okay, and it is my C, so it is approximately same as this. Okay, this is approximately same as this I say rather this is same as this. So now what will happen? So this implies the error is, so this implies the rate of convergence is 2 here, right? Second order. Similarly, we can bring it to higher order. Now if we continue in this way, right, continuing in this way, I write it continuing in this way, let your phi dash zeta is phi double dash zeta, so on, phi n minus 1th derivative at zeta is 0, but your nth derivative is not 0, right, is not equal to your 0. Then what will happen? Then from your equation star will this term will remain, okay, your epsilon n plus 1 will be equal to epsilon n plus 1 is equal to your epsilon n to the power n by n factorial, epsilon n to the power n by factorial n phi nth derivative at zeta. Okay, if you bring this as a constant, say, okay, this as a constant, say, then what you will get? So this implies here en plus 1 mod is approximately same as some constant times en mod to the power n. Okay, now this n here, this n is here the order of convergence. Okay, so this implies the order of convergence is here n, right? Hence the order of convergence of fixed point iteration method is of order 1 to up to n, right, depending upon the derivative of phi x in the interval where the roots contain. Okay, so this is what the rate of convergence here. Now coming to the rate of convergence of Newton-Raphson method. So now we will discuss the rate of convergence of Newton-Raphson method. So Newton-Raphson method is also an iterative method, is not it? So NR method is also an iterative method. So in view of your fixed point iteration method, what is the condition of convergence here? Condition of convergence here. You know the necessary formula is xn plus 1 is equal to xn minus fxn divided by f dash xn. Okay, f dash xn. So I can say it. So now in view of your iteration method, right, here x is equal to phi x. Okay, so what is my phi x now? So my phi x is equal to x minus fx by f dash x. Okay, f dash x, right? So in view of your fixed point iteration method, we can resemblance it to this with this. So now what is phi dash x here? So what is your phi dash x? So this implies my phi dash x is equal to, you just find the derivative, right? Derivative of x is 1 minus, this is the division formula, second derivative of first f dash x, again here f dash x, right? Derivative of first is here f dash x minus first derivative of second is here f double dash x divided by second square f dash x square, is not it? So this just you add it. So this is equal to f dash x square minus this into this is your f dash x square and minus plus fx f double dash x divided by f dash x square. So now this and this cancelled. So this implies, so this is equal to here fx f double dot x by f dash x square. Okay, f dash x square. So now in view of here phi dash x less than 1, phi dash x mod less than 1. So what does it mean? Fx into f double dot x by f dash x square mod is less than 1. So what does it mean? So this means here fx into f double dot x is less than here f dash x square. Okay, so this is the condition of convergence for NR method, right? This is the condition of convergence for here NR method. Okay, so now let us see what is exactly the order of convergence here. Under this condition, this NR method will converge. As I spelled out earlier, what is the convergence criterion for NR method? So this is the criterion. So now exactly what is the rate of convergence we'll find. Now let us find exactly what is the rate of convergence of NR method. Consider the equation. Consider the given equation. F of x is equal to 0. Let zeta be the root of this equation, with epsilon n as the error in nth iteration. So what does it mean? That is my epsilon n will be xn minus zeta, or here xn is equal to en plus zeta. Okay, now what is the necessary formula? The necessary formula for NR method is xn plus 1 is xn minus fxn by f dash xn. Okay, so you substitute this, the value of xn you substitute here. So what does it mean? So xn plus 1 will be likewise epsilon n plus 1 or en plus 1 plus zeta, and xn will be en plus zeta minus f of en plus zeta divided by f dash en plus here zeta. Okay, so now here zeta cancelled in both sides. So this implies here en plus 1 is en minus. Now you just find the Taylor series expansion of these two. Okay, you find the Taylor series expansion. You know what is the Taylor series expansion? You know f of x plus h is fx plus h f dash x plus h square by factorial 2f double dash x, so on, is not it? So this is your Taylor series expansion. Now you apply the Taylor series expansion here to this function as well as to this function. So minus, it is f of zeta plus en f dash zeta plus en square by factorial 2 f double dash zeta plus so on. So now in the denominator f is replaced by here f dash, it is f dash zeta, right, plus en f double dash zeta plus en square by factorial 2, okay, f triple dash zeta, and so on. So now suppose in the denominator let it be my 0 here. Okay, because epsilon n is a very small positive number, and epsilon n square, epsilon n cube, so on will tend to 0. In the denominator let me write this is tend to 0. Okay, so now it will be my en minus f zeta plus en f dash zeta plus en square by factorial 2 f double dash zeta. I stop it here, and in the denominator it is my f dash zeta plus en f double dash zeta. Just you add it. Okay, just you add it. It will be En f dash zeta plus En square f double dash zeta, this will be, then minus here f of zeta, of course here f of zeta, zeta being the root, it is here 0 here, of course it is here 0 here, so it is my minus, okay, minus of this En f dash zeta, and it is minus of En square by factorial 2 f double dash zeta, okay, and divided by, in my denominator it will be my f dash zeta plus En f double dash zeta. Now this and this cancelled, En f dash zeta, En f dash zeta cancelled, okay. So now En square minus En square by factorial 2, this minus this, okay, it will give, so subtracting this from this, okay, I am getting, so this is equal to En square by 2 f double dash zeta. In the denominator, let I take common f dash zeta, taking common f dash zeta, so this will give me 1 plus En f double dash zeta by f dash zeta, okay. So I can write it, now I can write it now, here En square divided by 2, okay, and this will be my f double dash zeta by f dash zeta, and let me to write it as 1 plus En f double dash zeta by f dash zeta whole to the power my minus 1, okay. Now I can apply the formula, 1 plus x to the power minus 1 is 1 minus x plus x square minus x cube plus so on, so on, so on. I apply this binomial expansion now. So now I just expand it in this line. So this will be my En square by 2 f double dash zeta by f dash zeta, and it will be my 1, this is my x, okay, 1 minus x En f double dash zeta by f dash zeta plus x square En square f double dash zeta by f dash zeta square, and it is so on. Now you see this epsilon n square is again multiplied with this, okay, so these are now tending to your 0, okay, because here epsilon n q, epsilon n fourth, so on, so on, so on, are very, very small and close to 0, okay, very, very small and close to 0. Now if I multiply it, so this will be my En square into just this into this f double dash zeta by f dash zeta 2 into this. So let I say this is my c, okay, this is my constant c. So what will happen, so my En plus 1, consequently my En plus 1, so this implies my En plus 1 mode is almost same as c into En mode square, okay. So now this 2 is the order of the convergence, okay. So hence the order of convergence of NR method is 2, that is quadratic rate of convergence, that is quadratic rate of convergence. Now another question, the disadvantage of NR method, right. Now the moment this 2 is not always, okay, not always, mostly it is 2, but the coming to the disadvantage is in NR method, okay. Now if fx has multiple or repeated root at zeta, then the convergence is, then the order of convergence is 1, okay, that is linear, very slow, means slow, right. Again if f dash x tends to 0 or f dash x is complicated, Okay, then NR method is not helpful. As I have told you in my individual lecture of this NR method. Now just I will mention the rate of convergence of other methods without being the derivation. So here the NR method is not that much useful. Okay, but in this case we use your secant method. Okay, use your secant method. Okay, so without being derivation, I will now explain. I will just tell the convergence of other methods. So to conclude, we see the rate of convergence. Right, this is your zeta. If the rate of convergence of NR method is your 2 here, but whenever the root is a multiple root or repeated root, the convergence is linear, slow here. Moreover, if your f dash x tends to 0, denominator is 0, or f dash x is complicated to find out, then this NR method is not helpful. We use rather the secant method. However, in iteration method, the rate of convergence may be 1, maybe 2, maybe 3, maybe n. Right? If we get a well phi dash x, right? We know the condition phi dash x less than 1. So for your iteration method, we need your phi dash x mod less than 1. Okay, if you get it very suitable in AB, we get it very suitable in AB, then the root is very closer and the rate of convergence is high here. Okay, so now anyway this NR method is an ideal method except the multiple root cases. Now let me to tell you the rate of convergence of bisection method is here 1 here. The rate of convergence of regula falsi method is also 1 here, but the secant method is 1.618 and which is same as 1.62. Okay, so after this NR method, the secant method is next best method as far as the rate of convergence is concerned. Okay, so I hope this lecture is useful to you and interesting to you. If you feel this is useful and interesting, please like and subscribe to this channel. Okay, subscribe to this channel, which will boost my motivation. At the same time, you may hit the bell icon so that whenever a new lecture will be uploaded and it will come to your screen. Okay, so you can easily access the lecture. So with this, we should close this lecture here. Thank you all. Have a nice day.